For solids, no particular order: copper sulfate, copper carbonate, copper chloride, copper oxide. Use the information in the table to identify the solids A, B, C, D. Explain how the information supports your conclusion. So this is similar to a 6-mark question that appeared on the exam the other year. What we need to do, first of all, identify them all, but then we need to explain these observations. This is most important. This is where the marks are for explaining each observation. Particularly these are probably the electrolysis and the sulfuric acid, but try and say something about everything. Now, I've given you nowhere near enough spaces, so I'm going to keep my notes very brief. You really should try and enlarge on these. First off, let's identify A. So it's blue-green. Copper is every one of these, and copper is transition metal, so it shouldn't be any surprise we've got some bright colours here. Observation, blue-green solutions formed. So it's soluble. A is soluble. Okay, so if we remember our solubility rules, sulfates are soluble and chlorides are soluble. Carbonates and oxides are not. So this has got to be copper sulfate or copper chloride. Let's carry on down to the next one. Soluble. So let's say that there anyway. Chlorides and sulfates. Can't spell, can I? Chlorides and sulfates are soluble. Carry on down. Products of electrolysis. This is of a solution. We've got chlorine produced. Chlorine. So we can do ourselves a half equation now of chlorine being produced. But the chlorine being produced tells us it has to be copper chloride, doesn't it? So you're not going to get chlorine from a sulfate. So A is going to be copper chloride. We can identify that. So we have our chlorine half equation. Again, you need to explain this a little bit more, but if you've got chloride ions there in the copper chloride, they go to the electrode and electrolysis turns the ions back into elements, going to make chlorine gas. Chlorine gas is a Cl2 molecule, so you need 2 ions. These are negatively charged, so that's going to give off electrons as well. So that explains that one. Reaction with sulfuric acid. Okay, so H2SO4 is an aqueous solution, as is copper chloride. Now when you get these two solutions here, we can get a double displacement going on. So the hydrogen is going to take the chloride ions, the sulfate is going to take the copper. So that's going to be copper sulfate aqueous. Copper sulfate aqueous and 2HCl. Okay, copper sulfate aqueous, that, if you remember back to our core practical, is a blue solution. So that explains that line. Okay, B next. Right, B's blue. Blue solutions form, so it's soluble. Well, the only other soluble one here is carbonates and oxides are insoluble. That has to be copper sulfate, as we've already said. Now, copper sulfate, when it's electrolyzed, copper sulfate solution was electrolyzed. This was a core practical on electrolysis. The sulfate is not produced. If you remember, if it's copper sulfate aqueous, it also has hydrogen ions and hydroxide ions from the water. Well, the hydroxide ions are going to be heading towards the anode in this case. So again, I'll just do a half equation. You really should try and explain this a little bit more. When the hydroxide ions touch the anode, they make an oxygen molecule and water molecules, especially if we have 4 of them, that's now balanced. 4 hydroxide ions, each hydroxide ion is negatively charged, that's going to give off 4 electrons. So that's our half equation for the production of oxygen gas. So that's why oxygen is produced. C. Right, so it's green, both insoluble. So this is going to be either the copper carbonate or copper oxide. D is black. I don't know if you remember the core practical we did of taking copper oxide and reacting it with sulfuric acid. The copper oxide was black. So C, therefore, is going to be the copper carbonate. Okay, but let's just check the rest of the observations. Okay, because it's insoluble, copper carbonate is insoluble, poor conductor of electricity. It's ionic, but the ions cannot move in the solid lattice, poor conductor. As ions can't move. And that will be the same, we should say the same thing for D as well. But again, I'm short on space. But if you're writing a fuller answer, you really should say that. Right, copper carbonate with sulfuric acid. So Metal carbonate. There is 4 neutralizations we need to know. Metal carbonate is one of them, plus acid. That makes salt plus water plus CO2. CO2 is a gas, and that is the air for the effervescence. Okay, so this is another bit of information that says this has to be the carbonates because we've got effervescence. We've got a gas given off. The CO2 is the effervescence. D. Right, so the only thing we've left to talk about here now is the reaction with sulfuric acid. So we're saying D is copper oxide, if you remember. So D, we need to say that as well, copper oxide. Okay, so copper oxide plus sulfuric acid. So this is metal oxide. This is another neutralization we need to know. Metal oxide plus sulfuric acid makes salt plus water. That's going to be copper sulfate, and this was, as I said a moment ago, one of the core practicals you did in year 10, plus water. Copper sulfate is again a blue solution. Okay, so nowhere near enough room to write a proper 6-mark answer there, but that is the type of detail and a bit more that you need to go into to get 6 marks. All these questions on elshamhighchemistry.com.